I'm Jake. We're back in the Holland built shop with another video powered by SendCutSend. In the last video, we built this rear upright. In this video, we're going to be making the frame mounts for the radial arm and the toe link on the chassis. So let's get into it. So when we designed the rear uppers in the last video, we were working around the wheel geometry, the hub geometry to fit it all in there. Now that we have these uprights made, we furthermore solidified the geometry of our rear radial arms and our toe link with respect to the wheel. We also have the rear clip is pretty much fabricated, so we have all the roll cages kind of in a fixed place. When we put those mounts in on the radial arms on the rear suspension, we can change how this wheel is going to travel in its up and down orientation as we go through whoops or jumps, that kind of stuff, right? Or even corner. What we're going to do is let's go ahead and make a quick 3D model, and we're going to place it down here on the table to talk about how changing the geometry aspects between the upright and the chassis can affect the suspension as it goes through its travel. So now that we have a model fresh off the CO2 laser in cardboard, let's talk about what these individual points that we're going to be using are referencing. On our upright, we have 3 points of contact, right? So we have an upper, our toe link, and our lower radial arm. And these are going to be fixed. Our toe link is actually centered in our hub. And I did that because the CV is obviously centered in our hub. And so our toe link and everything is all perfectly straight through. These upper and lower mounts are going to be tied off the center, and they're actually symmetric. And so we did that all just to ease the geometry design in the end. So as we come down here to this model on the cardboard, we can see we have 3 points of contact. And this is just a reference. This is obviously not to scale, but I want to talk about how it cycles through. So if we have that upper radial mount, the toe link, and the lower radial mount, as this, we're going to say this is the chassis side, and this is the upright on the wheel. If we mimic that geometry on both sides and make it perfectly symmetrical, as we go up and down through that cycle, we can see that we actually keep that wheel completely perpendicular to the ground. So as it goes through its full cycle, we can drop all the way down, and we can go all the way up, and we can see here that we stay nice and parallel or perpendicular, I guess, to our ground as we're going through that cycle. So let's say change that up. Let's go ahead and say that on our suspension, we can't have an ideal setup on our chassis. And we're gonna end up making it so that our chassis mount now has a lower point of contact because there's interference where we want it to be. So let's change this out. So if we take these off, so if we take these off and say we want that wheel to be nice and zero camber at suspension, we had to keep this vertical, say. As we go up and down, we can see now we end up getting a wedge type thing. So we're going to be adding and subtracting camber as we go through the cycle. The reason why we don't want to end up having a suspension like this is that, say we go all going through some whoops, right? And the suspension is traveling on each rear wheel since we're independent at different rates. One wheel can be coming up and losing contact with the ground because we're not going to have a nice flat tire patch anymore. And we can start to get the car to hop back and forth on us, making it hard for the driver to keep control of that car. So as we're moving forward with this design and trying to put those suspension mounts on the car, we're going to be trying to keep in mind that we want to keep that geometry that we have on this hub the same with the chassis on the other side as much as we possibly can. So let's go ahead and let's go to the CAD software in my office. We're going to see how ideal we can make this suspension, and then we'll put it in the cardboard and give it a check. So going off of those models that we just talked about in the shop, we know now how that geometry can affect the tire's travel as we go through an up and down movement in the suspension. So taking that knowledge that we just learned from those models, let's go ahead and look at this and see how I kind of played out the geometry around the different components that are in this rear suspension. So as I pull this up, we have that rear upright that we've already made in the last video. And then we have the rear differential, we have the brake rotor, which is going to be kind of playing into a part as it's kind of coming into the area in which we're connecting these radius arms in the rear suspension. We can see how the mounting is tying in, and then we have that cross bracing in the back. So what I'm thinking is that what we want to make sure we mimic, right, is that center orientation on the hubs with respect to the radius arm mounts and what we call the toe link, right? And so the toe link is important in this because what we would consider bump steer in the front suspension, we can also get in the rear suspension if we have the setup. So if this particular arm is not equal within that geometry, as the tire goes up and down, it can actually turn inside and outside. So actually the rear tire would be turning in and out, just like the front suspension. If this is happening in the front suspension, what you end up seeing is the car will toe out and toe in over bumps, or vice versa. In the rear, what that would do is probably just kind of make the car unstable as you're going through bumps. And so what we want to do is minimize that. And so we're going to do that same thing with the geometry. If we look at it from this angle, we are going to have a slight radius out within respect of the center, but that angle actually doesn't matter. So as the radius is going to travel, it's an axial radius. So we're looking at it only from this point of view. If the rear tire was wanting to move forward and back, then we'd worry about the other one. But as we're just moving up and down, then we should be in pretty good shape to not have any issues with that. Lastly, what I'm going to end up doing is we're tying this in with several different bent components that are going to be tab and slotted into the design. As we weld all those together, it's going to turn into one cohesive design. So let's zoom in here a little bit. We can see here that this like individual part is going to be one piece that gets tied over to this part that comes in one piece. We're going to have this big back plate that's going to act as a big back support that gets tied into the main crossbeam. And then on the back, we have a top section that gets tied in, and we have all this kind of gusseting that's going to essentially tie back into the center. If we have both of them doing it this way and we add maybe some extra bars in the end, we should have a really good stable rear clip that we can rely on. So now that we kind of looked at it, I was actually able to get the geometry from what I consider perfect. The main points of contact as well as the axle centers on the CVs are all perfectly lined up, and they're all the same spacing. So when we had that model in the shop that tracked perfectly up and down, I essentially replicated that into this suspension geometry in the rear. So now that I'm really happy with this, we're gonna go ahead and go do a quick test fit, add a cardboard off the CO2 laser, and then once we verify that, we'll move forward. So I will see you out in the shop with the CO2 cardboard template. So once again, we got another 3D cardboard model that's hot off the CO2. I ran out of hot glue, so I used blue tape. It's not making me happy, but it is what it is. So let's go ahead and take this over to the car now and see how it kind of works around that rotor and it works into the chassis like we're expecting it to. So once again, we have this rotor, and then we have these 2 points, essentially the flat bottom on this and then this face here that we're going to be kind of using as our reference. So we have that cutout on the bottom here. That's going to be a good indication of where we're at. And as this kind of slides up, it looks like everything is lining up exactly like we wanted it to. And that's just because we kind of took the time, on the CAD to do the work that we wanted to do. We can see here we have a nice amount of clearance in here on that rotor. The calipers are going to be mounted either here or in the front. I haven't decided where I want to put them yet. But we can see if we come from the back angle here that we have a nice alignment vertically in this orientation that is going to be lined up with that CV axle on our rear end here. And our orientation is the same as it was on our upright. So as this wheel travels up and down, it should be just like on our model where it stays nice and parallel, or it's set to whatever camber that we want it to stay at. It's gonna be relatively consistent as it goes through its travel. So now that we have that kind of figured out, we're gonna go ahead and create a mirror image of this entire setup for the right side. We're gonna put it into SendCutSend's website, get these cut out and bent, and then we'll see you back here in the shop to get it all welded up. So now that we got the actual metal parts back from SendCutSend, everything looks like we want it. This is just the driver's side one. We have all of our parts are now bent, and we have some parts that are gonna be doing that hand bend that we normally do in our designs. We have our tab and slot design that we're gonna be implementing on this. So let's go ahead and look at it a little bit closer and do a quick dry assembly to make sure we have all the parts correct, bent, and in orientation. And then we'll clean them up, get to the welder. So I kind of laid them out, knowing a little bit where the parts need to be. But it's kind of cool. We have this nice tab and slot design. The parts pre-bent, and they kind of slide right into place. Again, I left a little bit of wiggle room in these so that we have an easier assembly, because we're not going to be talking about having tenths of an inch making a difference really in the suspension geometry. So we can kind of keep putting these in place. We're going to have a nice seam weld here. We might have to switch over to something else to weld up on the inside. We put this one in place. This plate right here is going to end up coming in and laying into this bed right here and connecting into this for our design. We have kind of a dual purpose design here, so we're going to end up actually putting in this tab first and dropping that into place here. Should snap into place. There we go. Okay. So the last thing is that I ended up turning some spacers on the lathe, and what these are gonna do is they're just gonna slide in between these two. We're gonna put a bolt in there. That's gonna keep it all nice and square. It's gonna set our distance in there, so when we get our heims, I'll make spacers that hold it into that, that orientation. So we get a good clamp on our suspension. So let's go ahead, clean these up. They have a little bit of oil and stuff and some burrs, since these aren't ran through the deburring process at SendCutSend due to the, having them rust and stuff and post-processing. So we'll do our weld prep and get after it. We're done with the welding that I can do at the table over there. We're gonna go ahead and start fitting this into the car. There's gonna be a little bit of wiggle room. Like I said earlier, 1/8 inch, isn't gonna make or break the suspension design. We're gonna be able to tune that out with the heims that are on the suspension. So we're gonna be mostly just trying to get this in there, lined up nice and square, and then we'll get to welding it in. So let's check the fit now. So since we have this right here, we're gonna end up hand bending this down into the other side of the gusset that's gonna be on this side, but we don't really wanna put it in place yet, so we have room to get it in there. So let's go ahead and put this up in. We kind of have two spots that we can use. The first spot is right here. So then that lower two, we have that nice notch. That's gonna indicate that that's in the right spot. And the second is essentially we have this nice bend that was CNC bent. That's gonna come into play, and we're gonna pull this up into the corner. And then lastly, we have a nice line here that we can look at and see, cosmetically it should be close to the center of the pipe. you know, we're playing with a lot of tolerances right now of me putting in this pipe at one point, and you know, we have these cut, so we're not gonna be perfectly in the center of the pipe. I don't think that's gonna be too much of an issue. Lastly, we're gonna have this last gusset we're gonna put in, and then this one just slides in and butts up against the back of that one. And we're gonna slide it down until we like this spot. Feels like it's in the same spot on both sides. I'll go ahead and put a spring clamp on this here and here. That should hold it for us kind of where we want it. And we can make any moves. Really happy with that fit. What I'm probably gonna do is I'm gonna make some welds up in here before we bend this down. And that's gonna allow me to get a little bit more strength, a little bit more tied together. And then once we bend this down, we'll weld this one in. We have that other plates that are gonna tie in this, as well as the other gussets that are gonna be hand bent. So we have one in here that we're gonna place in, we'll weld it up, and then we're gonna hand bend it over, and then we'll weld in the rest of the seam. And then this one's a simple, just single gusset that's in that corner. So let me get the welder on. We're gonna get this tubing cleaned up, and we'll get to welding some more. All right, guys. So I just did that one hand bend that we have on that. We're gonna go ahead and start tying in all these gussets. I have everything kind of tacked up. It's looking really good. I have a lot of welding to do. We're picking away at this project. I wanna thank you guys for watching and stay tuned for more.